So this is going to be how to diag a no crank, whether or not it's going to be the starter motor itself or the ignition switch of the circuit. So here's the wiring diagram. Let's take a quick look at this real quick here. So first thing on the top, we got ignition switch. If you don't know what an ignition switch is, ignition switch sits in the column here, attached to the tumblers. When you turn the key on, it changes the switch position and then commands the starter motor on. Okay, so what's next? We got some wiring, pretty simple, and then we have a clutch start switch, which is the neutral start switch, which is attached to the clutch pedal. So which, by the way, you can bypass by taking these two wires on this connector here and tying them together. This car is not very happy. As you can see, it's been sitting for a while. So if this was an automatic, it would go through the parental switch, which gives it two different ways. It can go through park or neutral, which is not on this schematic, but these two serve the same purpose. It interrupts the starter in case the thing's in gear. It won't allow it to start in gear. Okay, so we go down through here. There's a connector. Okay, so down through here. Now we're in the interior, the underhood PDC, power distribution center, fuse box. You know, whatever you want to call it. Every manufacturer has their own term for it. So we go through the fuse box. There's this very interesting splice right here. We'll get into that in a second. So power comes all the way through the ignition switch, through the neutral switch, through this connector, through the starter motor relay, and then to ground. And that allows the solenoid to pull the pintle in and get the motor to start spinning. So there's another very interesting thing here. What can we learn from this wiring diagram? So this interesting splice here comes up to the cooling fan relay. So what does that mean? Well, what that means is when the keys turn to the start position, it actually opens this relay for the cooling fan, which, what does that mean? It means that it forces the fan to turn off only during cranking in order to save voltage. So let's take a look at that. Okay, so here we go. Here's our main cooling fan relay, which is this one in the diagram. So what does this do? We'll get into that a little bit more in depth in the cooling fan one. But there's a couple very interesting things that we can do from this point. Okay, so according to our wiring diagram here, we have power side and a control side. This is a control side, by the way. So what do we got here? We got hot at all times, 40 amps. So if we go off our ground terminal over here to this pin, what are we going to see? Okay, cool. So we got 12 volts there. So the other side of that, if we stick that in there and then supply power to that, okay, interesting. We also got 12 volts there. So what does that mean? That means that this wire is being supplied ground through these other relays, through the blower, or not the blower, but the cooling fan to ground. So it won't get into that right now, but so what does this mean for us? Okay, so there's a couple interesting things we could do from this point. So we know we got power on that one. So let's take our wire here and jam it in this other one, see what happens. Okay, so the fan runs. We'll get into that one later. But if we take a look at our wiring diagram, okay, so since our cooling fan relay is interrupted by the ignition switch, we can use these other two ports to do two things. One thing we can do is, if we hit that, we can backfeed power through the ignition system. Okay, that's cool, whatever. What does this one do? Oh, that's really interesting. So what does this mean? This means that if you're in a position where you have a no crank, all you have to do to verify if it's the actual starter or the control side, without any variations in, corroded ground terminals or anything, you can just jump these two wires together right here. See if the starter runs. And if it does, then you can test to see if you're getting a signal from the ignition switch. Okay, so if we hook our signal wire up there and then to ground with our voltmeter, we should see 12 volts on there, which we do. So this is going to be kind of hard to film this, but what are we going to expect to see here when we hit the key? So the voltage dropped to 0, and that is because the ignition switch interrupts this cooling relay. So as long as there's a drop of voltage to 0, you can verify that your ignition switch output is running. Okay, so the last interesting thing we can do here is, just gonna have to trust me on this. It's kind of hard to hold and do this, but the key is off. So with what we know before, we can back feed power through the ignition, wake the PCM up, and we can also hit the starter. Well, isn't that interesting? I'll get that one out of there. So, ignition is off, key is sitting on the seat, but the vehicle's running because we're back feeding power to the PCM through the ignition switch. So that's very interesting. So what have we learned from this? We've learned that the system is pretty damn simple. There's not much to it. And also, conveniently, the engineers have given us a convenient test point to test multiple things. So you could do all kinds of stuff with this. You could test your heart out. I don't know. I'm kind of excited about it. I don't know if you guys are excited, but I'm excited. And the coolant fan one we'll touch into a little bit later. But this is just a start. So there you go. That's how to test and apparently hotwire your car all in the same time from one spot.